Hi there, I'm Jim Zirin. Welcome back for more conversations. Today we will talk about science. Richard Lifton is with us. Rick is the 11th president of Rockefeller University, a gem of a research institution located on Manhattan's East River that has boasted 24 Nobel laureates on its faculty. Founded in 1901 by John D. Rockefeller Sr., the university's 77 laboratories conduct both clinical and basic research aimed to battle our most dread diseases. Rockefeller offers postgraduate and postdoctoral education in furtherance of its core mission, science for the benefit of humanity. Rick is a physician and geneticist with a special expertise in genome sequencing, analysis of genetic material to predict the occurrence of hereditary disease long before diagnosis is possible. Since its founding, Rockefeller has featured an open structure to encourage collaboration between and among disciplines. There are no formal departments, and scientists are given resources, support, and unparalleled freedom to follow the science wherever it leads. We're pleased to welcome Rick Lifton to the program.
Thank you very much, Jim. It's great to be back.
Well, it's terrific to have you with us. You have an important institution in our community, and we're very grateful for it. Tell us something about it. How many students, how many PhD candidates, how many postdocs?
Sure. So Rockefeller runs, as you mentioned, with faculty who pursue the most audacious science that they can. And they're helped by 270 graduate students and about 300 postdoctoral fellows at any one time. And it's an amazing environment of extraordinarily talented and innovative scientists.
Now, how many students do you have who are foreign students?
About 40% of our faculty and our students and trainees are foreign-born, and they come and enrich our community and continue to do great science. Many of them stay in the United States, some go back home, but we're grateful to get the best people from around the world to come to Rockefeller.
And these students don't just come from the New York area, they come from all over the country, those that are American, is that right?
All over the country and all over the world. We have students and postdocs from almost every continent.
Now, we all hear, at least those of us who read the New York Post, that New York is in decline. People don't want to live here. People don't want to come here. What has been your experience with applicants who are thinking of coming to Rockefeller?
Well, you know, everybody got nervous during COVID, but we've seen a tremendous rebound. We had the most applicants we've ever had this year for our graduate program, and it's extremely competitive to get in. And the same with postdoctoral fellows. You know, it's a challenge getting postdocs from around the world as immigration has become more controversial. We've had problems with even having postdocs with visas have a difficult time getting back into the country if they go home and to visit family and come back. There's some airports that they come through that they really have problems getting through.
Now, have you divided your laboratories into specific fields?
No, we recruit the person, not the field. Every year that we do a search, we're looking for the most innovative scientists coming out of their postdoctoral fellowship anywhere in the world and recruit them to come join us and be part of this amazing community.
Now, you're the president, you run the show, but you have a lab of your own there, don't you?
I do.
Well, tell us about that.
Well, you know, I'm a geneticist, I'm a physician and a geneticist by training, and have done human genetics since the field really became robust in the 1980s. And we took a then audacious approach of trying to understand the most common cause of death in the human population worldwide, which is hypertension. And
it kills high blood pressure.
High blood pressure kills about 13 million people a year. And
wow.
When I came into the field, it was hotly debated whether it was a disease of the heart, the brain, the blood vessels, the liver. the kidney, and we scoured the world looking for the most severe forms of high and low blood pressure that were compatible with survival, and used the then emerging tools of human genetics to figure out the specific genes that can drive blood pressure to either the highest or lowest levels compatible with life, and showed that these all converge on how the kidney regulates blood pressure by the reabsorption of salt and water.
So is it the case that everyone who has high blood pressure has high blood pressure from the same origin?
So it clearly plays an important role in virtually everybody who has high blood pressure, and most of the tools that we have now to treat high blood pressure attack various aspects of how the kidney handles salt and our appetite for salt as well. And the therapies continue to evolve and get better, and there's a drug that is in clinical development now that I think is quite innovative, that has the ability to knock down blood pressure reliably with a shot every 3 to 6 months. And that would be a major advance for the treatment, where taking a pill every day is not a great thing for many people to do. But hopefully with a drug like this, we might be able to stay on medication for the rest of one's life without too much trouble.
And is it the case that some people have hereditary high blood pressure and others have it because they're putting too much salt on the steak?
Well, salt certainly plays a role, and people who have varying sensitivity to salt in the diet. But the people that led us to our conclusions were the people who just have extraordinarily high or extraordinarily low blood pressure from birth onward, and figuring out the genes that are involved in those causes of hypertension have provided insight into the more common forms as well.
So aside from this discovery, this breakthrough, what would you say were the major breakthroughs that Rockefeller, say, in the last 5 years?
Well, certainly during COVID, there was a lot of activity. As you know, we knew nothing about the virus or how it was going to evolve and who was susceptible to getting severe disease and who was not. And so investigators at Rockefeller really led the way in showing the specific role of the immune system and which parts of the virus the immune system reacts to by making antibodies that can prevent the virus from infecting cells, and then predicting which mutations were going to appear in the virus over time that were going to evade the immune system and lead to the need for additional or evolved vaccines. In addition to that, inherited mutations that predispose people to have particularly severe disease outcomes identified key roles of the interferon system in the body, which is one of the body's alarm systems, to say there's a virus circulating, shut down all unnecessary functions until this threat is past. And that system plays a major role in rare patients who have severe disease who would be unexpected to get that otherwise.
Well, you talk about mutations are changes, and isn't that one of the devilish factors that elude researchers?
Well, so this is a critical element, that viruses are very clever and can adapt to the immune system by knocking out the bits that the antibodies can attack. And so they're constantly mutating, and that's part of their advantage, but it's also an Achilles heel, because if they mutate too much, too many mutations, changes in the DNA sequence or the RNA sequence in these viruses, they don't work very well anymore. So it's a two-edged sword for them and for us.
So what's an RNA sequence?
So this is DNA
What's DNA?
So DNA is the genetic material that is encoded in our genomes and sits in the nucleus of every cell in the body. And RNA is the messenger copy of specific pieces of DNA that's used as the template to make all the proteins that are made in our bodies. And so there are some viruses that use DNA as the genetic material, but others that just skip the DNA and only operate through relatively short pieces of RNA that comprise their genomes, and they copy those RNA bits over and over in order to replicate as viruses.
So is it a difficult task to analyze all this in terms of discovering causes of disease and cures?
So over the last 30 years, it has gone from being incredibly hard because we didn't know what the sequence of the human genome was, nor of other organisms. And now we know all of the genes in the human genome. It took just a matter of weeks from the identification of the virus to know what the complete genetic material in the SARS-CoV-2 virus that causes COVID was, and from there to make effective vaccines for SARS-CoV-2 in record time. You know, when the pandemic started, you know, we thought, boy, we are really in for it, and who knows how long it's going to take to make a vaccine, if it'll be possible at all. And to have the vaccines developed with this unique then mRNA technology was really revolutionary and saved millions of lives.
So Rockefeller was involved in the battle against COVID, and eventually a battle that has been in large measure won. But what other breakthroughs have you had in the last few years?
So there are spectacular stories that are coming out, not just from how the immune system works, but aspects of how the brain works that are really one of the great mysteries remaining in biology. One of our investigators, a young woman named Priya Rajasethapathi, is investigating the molecular determinants of how memories get stored and retrieved over time. And this is one of the major mysteries of how do we make memories, how do we store them, how is it that we retrieve them, why is it that if we recall a piece of a memory, suddenly other aspects of what was happening when that memory was formed come flooding back to us. You can think when you hear a piece of music and suddenly you're back to when you were a kid hearing this music for the first time. And she's really identifying these unique molecules that are involved in determining the variation in why some people have very good short-term memories and other people don't. It's obviously relevant to diseases where our memory gets faulty, as in Alzheimer's disease and other neurodegenerative disorders. So this is a really very exciting area of research.
One of my friends told me, he said, I have Irish Alzheimer's. I only remember my grudges. Is that involved with the genome somehow?
That I can't swear to, but it's an interesting observation.
So we have work that you're doing. How does this evolve? I mean, you have a scientist without a field but an interest, and the scientist says, all right, I want to get into memory, and then other scientists join in and collaborate. And
yes, and so
is that how it works?
A new faculty member will come to Rockefeller and start recruiting graduate students who come into our graduate programs to come work in their laboratories, start a small lab. Work goes well. People as postdocs start becoming attracted to the laboratory. And pretty soon you've got a lab of 10 to 20 people under you doing work that you're directing, but not so much doing the day-to-day hands-on work as much as analyzing the results and helping devise what directions to go next.
Okay, so one of the tasks, particularly as one grows older, is to remember things, short-term and long-term. And another task is to lose weight, notably weight. Now, has Rockefeller been involved with weight loss recently?
Well, so Rockefeller is well known for one of our scientists, Jeff Friedman, who discovered a hormone called leptin that is made by fat cells normally and informs the brain about how much energy storage you have around the body in the form of fat. And the role of leptin is to tell you to stop eating so much and to exercise more when you have too much fat and are obese. So the discovery of leptin really changed the way we think about obesity as not being a failure of will, but having a very strong biological basis. Leptin itself has turned out to, if you're missing leptin and can't make it at all, Children with this deficiency are massively obese from very young ages, and replacing leptin in those children is profound and really restores their body weight to normal. But for most adults who are obese, leptin doesn't have a great effect for reasons that aren't entirely clear. But most recently, as has been in the news, there are new molecules that are having profound effects on weight loss, and these are the GLP-1 proteins that are injectable, as well as some derivatives of them that may have even larger effect. And these were, in fact, discovered by a former graduate student at Rockefeller when she was working at Massachusetts General Hospital. And this is a woman named Svetlana Moisov. And she's now has been back at Rockefeller for many years, continuing as a research scientist at Rockefeller. And she discovered GLP-1 and showed its role as having the ability to lower blood glucose as a diabetic, anti-diabetic agent. And that was extremely important drug for type 2 diabetes mellitus, which is common in the adult population. But it wasn't appreciated until scientists at the pharmaceutical company Novo Nordisk were able to increase the half-life of the protein to allow you to get high levels of GLP-1 in the bloodstream. And this not only was a better...
Is GLP-1 is a drug?
Yes, so it's a short peptide that's made as part of a larger protein, and Svetlana identified the piece that was chopped out that would have this effect on blood glucose. But then when you were able to go from just getting a tiny amount of it in the bloodstream for a short time, get very high pharmacologic levels of the protein, that people notice, wow, it's a great diabetes drug, but people are losing weight like crazy. And this has turned out, this is the drug that now is Ozempic and Wegovy. And it obviously not only has profound effects to reduce obesity and cause about 15% of body weight loss, but that effect has turned out to also have marked effects to reduce the risk of heart attack in people who have had a heart attack previously. And there are likely other disorders that it will prevent as well. And it's under active investigation for reducing progression of kidney disease toward kidney failure and potentially reducing the urge to consume things other than calories, such as alcohol and other drugs. It's not settled yet, but these are under active investigation.
So are these incidental effects of weight loss, or are they direct effects of taking the medication?
Well, so we've known for a long time that obesity tends to go along with elevation in other lipids that we know are such as LDL cholesterol that accumulate in the blood vessels and cause coronary artery disease and cause heart attacks. So this kind of weight loss likely has its effect through these mechanisms of lowering other blood lipids to low levels, but also probably lowering inflammation, which is plays another important role in cardiovascular disease.
Okay, let's switch the subject. We've become conscious of the tremendous politicization of science. It's an issue in the presidential campaign. A third-party candidate, Robert F. Kennedy, says he's anti-vax. He doesn't like vaccinations. His running mate, Nicole Shanahan, says there's no scientific consensus that any vaccination does any good for you. Is that true?
So yeah, to say that there's no consensus on vaccines, there's no consensus outside virtually every responsible physician.
Essentially, these candidates that deny the efficacy of vaccines are disagreeing with facts.
No question about it. And the fact that we don't have hospitals for pediatric infectious disease anymore, I think, is strong testimony to the impact of vaccines. And we can see the risk of this, of the ability of vaccination that eliminated smallpox, real scourge of the world, is now gone from the earth because of aggressive vaccination worldwide. And that's, pretty compelling evidence of the power of
And let's
vaccines.
not forget polio and latterly COVID.
All of these diseases have, we've really been helped. I shudder to imagine where the U.S. Would be had we not been able to get vaccines for SARS-CoV-2 in the first year. Estimates now are that somewhere between 1 and 3 million lives were saved by the early deployment of the SARS-CoV-2 vaccines.
A recent argument in the Supreme Court involving the abortifacient drug mephistoprone, Justice Alito questioned whether the FDA is really a reliable source of safety, pronouncements of safety and efficacy with respect to new medications. Does that have any scientific basis?
No, we have the most robust mechanisms for testing the efficacy and safety of drugs that come into the human population. And the FDA is really the gold standard worldwide for evaluating the safety and efficacy of drugs that come to market. And this is really not a matter of significant question. I think it's fair to say that the SARS-CoV-2 vaccine was put into emergency use authorization because there was such pressing need for the vaccine. And it was fair to say, well, maybe if I'm not at high risk, I'll wait and see how things go. But now that we've had hundreds of millions of people vaccinated and the benefits are clear, risks are extraordinarily low from this and other vaccines that are currently being used.
Now, the plaintiffs in that case, the doctors, said this had never happened to them, but it was theoretically possible that a doctor might be in the emergency room and might be forced to treat a woman who had taken the drug and had a complication. And that's in a very, very small percentage of the cases, the statistics say, and that would be against its conscientious objective. I always thought a doctor had to treat someone and could not walk away from a case, but on conscience grounds. But apparently, federal law permits that in the case of abortion. What's your impression of the claim that, of course, the court rejected that because they said it was too speculative. But what's your impression of a doctor who won't treat a woman in an emergency room after taking a drug?
Well, yeah, my impression is that the claims in this case are people who have, may need DNC after use of a combination of these drugs with a partial miscarriage already occurring as a consequence of the drugs. And it's hard to imagine a physician who would deny treating patients in those circumstances.
Governor Hochul has said, leave the science to the scientists and medicine to the doctors.
Seems like a good idea.
And women's bodies to themselves. Do you ascribe to that?
These all seem like good ideas to me.
Good ideas.
It's remarkable that we're talking about turning the clock back 75 years now.
In this day and age.
Yep.
Rick Lifton, I have a question for you. This has been just marvelous. And my question is, are we likely to see cures for the dread diseases, the degenerative diseases, Alzheimer's, cancer, other diseases sometime in the near future?
It is an incredibly exciting time. In the last decade, we've gone from having either small molecules or antibodies as the sole way that we can treat disease with therapeutics. And we now have drugs that can correct the misfolding of proteins that treat cystic fibrosis. We can engineer completely new proteins to treat diseases like hemophilia by replacing the need for having the normal gene that is missing in patients with hemophilia. We can treat patients with RNA molecules that knock down the expression of proteins that are causing disease, and these are now FDA approved for about half a dozen different diseases. And then the CRISPR technology that has really just started coming to the fore, that now has FDA approval for both sickle cell anemia and thalassemia. Just the range of different technologies that are suddenly proving to have efficacy for the prevention and treatment of a wide range of diseases is really breathtaking, and we're really in the midst of a revolution in therapeutics. It's an incredibly exciting time to be thinking about the combination of great basic science and its application to the prevention and treatment of disease.
Well, this has been really wonderful and enlightening, and thank you so much for coming by, and thank you for coming by. Tune in next week for more conversations. I'm Jim Zirin. Meanwhile, be well, take care, and all the best.